Oh, we made such a nice logo for this project and now it's not there. That's really annoying. Okay, well, for the last 3 months of the year 2018, the Johanna Meesdorf Academy in Kiel paid me to make old data available. Data collected in the SDS stone artifact documentation system. And the data should not just be available, it should also be enjoyable. So how are we going to do that? How am I going to present that to you? First of all, I will do some old man rambling about data acquisition and sharing in archaeology in general. Then I will tell you what this SDS system is all about. And then I will tell you how we made this data available to you now. And in the end, I will conclude with some lessons for the future. So first off, data acquisition and sharing in general in archaeology. Well, archaeology produces a lot of data and often it produces bad data, which is by definition pretty shitty big data. So we could argue now whether archaeology produces big data at all, but I think you can say that in the form of bad data. Another big problem is that archaeology hasn't really a big tradition of data and of course code sharing. So there is a lack of data sharing. And of course there's also a lack of long-term storage strategies. I think that can be said for pretty much the whole field. Fortunately, there is light at the end of the tunnel. There are some solutions coming. For once, there are some positive pressure. There's some positive pressure coming from funding agencies and journals which require data sharing now. And there is, bottom up, this open science and reproducible research movement, and I guess many of you are kind of part of this, which demand data sharing, code sharing. And there's also the new developments concerning tools and enabling features to share data, which, for example, are data sharing providers like the famous Archaeological data service. There are data journals which allow to explicitly share and publish data. There is this data licensing movement which allows to make data sharing very, very clear and well defined. And there are new software frameworks that simplify good data sharing practices. And that's where R and Shiny come in. So let's talk about this SDS system. What is it? Well, there was a paper about 10 years ago about this. And in the abstract of this paper, we find a definition. So SDS is a recording system for stone artifacts. It's a compilation of different existing systems. And the idea is to make systematic and quantitative analysis of bulk stone artifact data possible. And that should happen by uniform coding and standardized listing. And this uniform coding should also allow comparative analysis. And that's very important, keep that in mind, digital exchange of this kind of data. So what are the features? Well, you're supposed to describe individual artifacts with the SDS system. And you're supposed to describe each individual artifact with about 200 variables. A big description, and there are about 1,300 predefined values and categories within this system to describe individual artifacts. This is supposed to happen with some kind of table layout, separate form sheets for individual artifact categories. And it's supposed to happen by value encoding, a digit-based value encoding system. So for example, 04 is supposed to mean 4 in the context of the color variable. How does this look like? Yeah, for example, this is a very tiny fraction of one of these form sheets. And you see there's some different variables, like for example, you can describe the site where artifact is coming from, and then you have 4 digits in this first big column to describe the site with a 4-digit code. So this is the first form sheet, or the very beginning of the first form sheet. You see it goes on and on and on, and there's a whole lot of different form sheets, and this is how these are supposed to interact and be combined in the end. It's very complex, and I guess you already imagine that it didn't turn out so well with so many variables and so many possibilities. SDS was implemented. It was used for about 10 years now. by on about 20 plus sites by dozens of researchers and students with no common supervision. We have a very interesting process coming here. You could draw phylogenetic trees of how the people adjusted the system for their needs. Cultural evolution. It's very sad that Enrico is not here. I guess he would love that. Cultural evolution is really, you can see that here. People got creative, found practical solutions to the problems they had with the system, like they eliminated this digit separation. We don't need that. We have Excel, we have spreadsheet programs. We don't need digit separation. They decided to ignore some variables, actually most of them. But on the other hand, they needed other variables, so they added new ones. And most importantly, they pretty much abandoned the idea of individual artifact collection, at least for most of the artifacts. They established some form of multi-artifact description form sheet with only about 20 variables. That's manageable. So, I mean, it was pretty obvious that something like this might happen, and the consequences now are that we have inconsistent and incongruous file structures with all these data sets produced with SDS. We have undocumented variables and values that only appear in individual data sets. And we have this absolute domination of the multi-artifact description system. So that's what you actually got now 20 years later. So what did we do now to make this kind of data accessible, searchable, and enjoyable? Well, five steps. First ones related to manual data preparation, and for the last three ones, R and Shiny came in. First off, we had to reconstruct the SDS user history, had to find out who actually used it, who were these people, and where did they put their data. So we had to hunt for SDS data on hard drives and forgotten network storages. What was really exciting, we found a lot of data, and then we had this pile of data, and we had to repair and document all these hacks people applied, or understand at least what they did. We had to establish a modern SDS layout, which actually works from a technical point of view. And we had to merge all these different form sheet tables which were created based on a tradition of manual artifact description in the field. So these for the data preparation steps, and now for data sharing. Here R comes in. First off, we decided to host these data sets. It's pretty much, so for the R package, it's pretty much independent, or it does not matter where you host this data, but most of it is currently in an online system which is called the Johanna Meesdorf Academy Data Exchange Platform. Most of the data is there. And we developed an R package, sdsanalysis, to access this data directly and to load it directly into R to apply further data preparation steps if you actually want to work with it. The most important of these data preparation steps is to increase the human readability. I told you about this coding system, like 04 equals green. I didn't know that. So we needed a way to decode the alphanumerical value coding scheme. And I did this with hashes in R, so it's very fast. There is a wizard function. You pipe in one of these SDS data sets and you get something human readable out of it. So this is basically the magic going on here. There's an R package just for this purpose. Go check it out. So now we have a way to load this data, make it available directly into R. And now not everybody's using R. We needed something to present it to the world. So therefore we decided to create one of these R Shiny web apps. Joe already talked about them. You can, it's running, it's working, it's hosted here. Go to it, check it out. You can explore different SDS data sets there and have some predefined plots which show these data and to give you an overview what kind of data is in a particular data set. You can explore multiple data sets. There's a map where you can see where we have data from and from which time periods and regions. So please take a look. That's the main thing I want to present today. Okay. So now, thank you. Some lessons for the future in the end. first off, if you design such a system to collect data, might it be stone artifact data or pottery data or whatnot, users will definitely ignore, modify, or even slaughter overly complicated databases and documentation systems. You have to keep it simple. That's one of the most important things I took out of this work with SDS. And if you want your users to use such a system and have a possibility for data exchange and data comparing data in the end, then you need supervision, not just concerning how you document and how you measure these stone artifacts, but also how you hack this data into the computer. You need technical guidelines. Very important, otherwise you get very interesting hacks. And then also you need to discuss long-term data sharing at the very beginning of a project. Because people and data, they vanish somehow. And in the end, you will go through old network storages, hard drive, searching for data, and maybe you are successful, maybe not. Maybe there is some meta information, maybe not. Maybe you are able to reconstruct hacks or not. That's something you have to discuss at the very beginning. Licensing is a very important help to enable this maybe from the beginning. And then for this session, scripting languages and web frameworks like R and Shiny, they can provide simple tools to make even complicated data very well available, visible and accessible. Thank you.